to this video tutorial on adding numbers and Gauss and how he approached this problem. It's another extension of our skeleton tower because we are able to pair something large with something small to basically get a rectangle. So here's what we did. We said we want to find the sum, and I'm going to call it S, of the numbers on the screen. We don't know how to do that easily, so let's do it again. Except we're going to write it in reverse order by pairing something large with something small, and then pairing something large with something small, and then large with small, continuing it on, large with small, large with small, large with small. Now the key to this problem is to add things vertically. So S plus S is 2 S's. And then 1 plus 434 is going to be 435. When we add 2 and 433, we also get 435. When we combine 3 and 432, guess what we get? 435. And as you go down the whole way, it's going to turn into just a bunch of 435s. So what Gauss was able to notice is that we're adding a lot of 435s together, which is really a multiplication problem. How many times are we multiplying those, or adding those numbers together? How many times do we multiply by 435? Well, here's the first 435. Here's the second 435. Here's the third 435. And this last one would be the 434th 435. So we'll put 434 in those parentheses. Don't forget we want S by itself, so we need to divide by 2 on each side. And we can just type it into our calculator then, and we will have the sum. So we're going to go with 435 times 434 divided by 2, 94395. 94,395. Perfect. Well done. So that's what we did with the Gauss problem, adding up consecutive numbers. There's our answer, and at that point we would be good to go. But there's also one more problem that we considered. What happens if you don't start at the number 1? So if we wanted to find this sum, well, we're going to call it S for sum. There it is. And we don't know how to do it, so we're going to again write it in reverse order, where we put the largest one first and the smallest one last. Behold, it's magic. Then what we are going to do is add the 2 columns, just like we did before. So S plus S is 2S. Now 234 plus 901 gets us 1135. So when we add that first column, we get 1135. When we add the second column, that's a bit easier to just do mentally. That's going to be 1135. When we add the third column together, guess what we get? It better turn out to be 1135 again for this strategy to work. Hopefully you're seeing how this is like a rectangle, because you're taking something big, pairing it with something small, and in the end, you're able to condense it to having a lot of the same thing. The question is, how many of those 1135s do we have? Now be careful, because although you see 901 here, we don't have 901 numbers written up top. Actually, the first number is 234. The second number is 235. The third number is 236. We want to figure out the nth number right there, that is 901. Now, here's what I think is the easiest way to do this. To go from 234 to 1, we had to subtract 233. To go from 235 to 2, again, we could subtract 233. Same deal here, subtract 233. So this n is going to equal 901 minus 233. And when I take 901 minus 233, I get 668. So there are 668 of those numbers written on the board. Now, sometimes people like to do this. They like to say, oh, well, I'm just going to take 901 and subtract off 234. And when they do that, 901 minus 234, it's 667. The problem is when you subtract 234, you're kind of ignoring this. You're basically putting a zero here. So if you take that approach, and if you understand it better that way, it's fine, but don't forget that you need to add 1 at the end and also get 668. So back to our problem, divide by 2 on each side, and the S, or the sum, turns out equal to 1135 times 668 divided by 2. Ooh, big number, 379,090. 379,090. That would be the sum of the numbers in the problem. Please, please, please make sure that you are very careful on calculating how many of those numbers are written on the board. If you do that, you should be good to go. And really, isn't this a nice strategy? It makes what would be an obnoxiously long addition problem fairly straightforward. And we thank Gauss for coming up with that method.